We saw in a previous video how to take an equation and plot a line from it. And it may be that you've even watched the video which produced these three lines on this graph. Just to recap, we made a table of values, we chose some x values, we used the equation with the x values substituted in to work out the corresponding y values, and then from that table of values we plotted the coordinates that we'd worked out, and then we put a line through those coordinates and labelled the line. But all of these pieces of algebra here, let's write them out underneath each other. Y equals 2x plus 3, y equals 3x minus 4, and y equals 2x minus 4. These all produced straight lines. And you can see that all of them have exactly the same kind of structure. They all start with a y equals. They always have a number, which I'm going to call m. Then there's always an x. And then there's a number. It might be a positive, it might be a negative, but I'm calling it plus c. And all of these three equations, which all took this format, they all ended up making straight lines. And it follows, well, maybe it doesn't quite follow, but it should at least be believable that this kind of algebra always makes a straight line. And it does. The trick now is to understand the significance of whichever number you put in here and whichever number you put in here. Now these lines, black, purple and red, let's just colour code them over here so that we can follow it a little bit more easily. There we go. These three lines have things in common, but there are obviously also things that are different about them. Let's start out with perhaps the most obvious thing. This black line is parallel to this red line. As they move up the graph, they're not getting closer together, they're not getting further apart, they're parallel. And you can see that the black line and the red line both have a 2 multiplying the x. And so that value of m, which I chose to be 2, but it could be anything, that value of m controls the steepness or the slope of the straight line. The proper word is the gradient. So that line, that number rather, controls the gradient or the steepness of the line. But if you look at the purple and red lines, both of those, well, let's start there. They have different gradients. That's why the purple and red lines are not parallel. But they do both share this minus 4 in the end. That's the same both times. And if you look at what's common to the red and purple lines, it's where they cross the y-axis. And look, they cross at minus 4, which seems to match that minus 4. And that's true. This is known as the y-intercept. That is where the line cuts through the y-axis. And so now it's possible to look at something like this and deduce, without plotting making a table of values, without plotting the graph, it's possible to take something like y equals 5x plus 3 and deduce what it will look like without doing all the calculations. So let's just have a think about that. Let's make up some questions to try. Suppose we had y equals 5x plus 3. Suppose we had y equals negative 2x minus 7. Y equals 14x minus 1. And y equals negative x plus 15. Fairly random. The key thing to start with is all of them do have that structure, y equals mx plus c. And so I can be confident that all of these, if I made tables of values for them, if I plotted the graphs, all of these would make straight lines. Let's deduce what we can from these. First of all, these numbers here, the 5, the -2, the 14 and the -1, let's just be clear, it's -1 just there. These numbers are controlling the steepness or the slope or the gradient of these lines. 5 is quite steep. 14 is even steeper. But these negative gradients, they're going to be downwards. They're going to be going downhill. This one is quite steep downhill. This one is not so steep downhill. But the critical thing at the moment really is just whether it's uphill or downhill. It depends upon, is this number positive or negative? Positive or negative? So we know which way the line is sloping. We also saw back here that the number on the end is the y-intercept. We saw that this -4 matched these -4s here. And so these are the y-intercepts. So I know this line is going to cross the y-axis at that point, at that point, at that point, and at that point. So what I can do really quite quickly now is I can plot is the wrong word, that implies a level of accuracy. I can sketch some graphs of roughly what these are going to look like, just to give me a rough idea. Okay, uphill through 3. There we go. Downhill through -7. Uphill, quite steeply uphill, through -1. And this one here, downhill through 0,15. Should have put a bracket on there. And so without much work at all, it's possible to get a good notion of what the lines ought to look like. There is one important thing to add. Suppose you had this, y equals 2 minus 3x. It would be very easy to assume that the first number is the m and the second number is the c, or the first number is the gradient, the second number is the y-intercept. Here that would not be true. Notice what's happened. The number multiplying the x is now sitting here instead of in that position. So it's helpful to rewrite this like that. The gradient of this is -3 and the y-intercept is at 0,2. In all of these, it's important that this is one single y equals whatever else. If it's not one single y, this does not work. You need to rearrange it so it is one single y. Y needs to be the subject of y equals mx plus c.